Okay, we're going to talk about section 3.3, part 2, the product and the quotient rule. Okay, so as I think I mentioned in class the other day, these rules are a little bit more involved than the power rule, but still, once you see the functions we're able to analyze, you'll see that these are, that the product and quotient rule will save you a ton of time over the definition of a derivative. So let's get right into it. The product rules. First, this is rule number 5 by my count, the product rule. All right, and it says this. Let's start by assuming that we have two functions, u and v, okay, both in terms of x. And this is what we want to do. We want to take the derivative with respect to x of the product, u times v. All right, so what we'll do then, or what the rule is we take the first function times the derivative of the second, plus the second times the derivative of the first. So it looks like this. U, so the first, times the derivative of the second, that'd be dv dx, plus the second, which is v, times the derivative of the first, that'd be du dx. Okay, and that's the rule. And then you simplify. Okay, so let's do an example here. Let's start off with one that is not too complicated. So we'll start off with f of x equals x times x squared minus 1. And what you could do here, I fully admit this, you could distribute the x and take the derivative using the power rule. Now, that is probably the best way to do this, right? But I want to start you off with this rule on a simple function rather than starting with something that's very complicated. Okay, so here's how we would do this with the product rule. Okay, so first of all, you identify what is your what is your first and your second function. So my first function here is x, and then the second function here is x squared minus 1. So you might think of this as, well, this is my u, and then this is my v here, okay? And then we'll follow the rule. So we take the derivative of f will be the first function, that's x, times the derivative of the second. So if we take the derivative of x squared minus 1, that would be just 2x. So times 2x. Plus the second function, that's our v, would be x squared minus 1. Times the derivative of the first. The derivative of x is just 1. Times by 1. And then clean it up, and that's it for the derivative. So you're going to end up with 2x squared plus x squared minus 1. And for your derivative then, your final simplified answer will be just 3x squared minus 1. All right, let's do another one. Okay, let's start with something, let's do something that would be more work to, where the product rule actually I think saves you time and work. So let's take f of x is equal to x to the negative 2 plus 1 times 4x cubed minus 3x squared plus 1. Okay, so this is a situation where, let's actually just go right to the top. This is a situation where you could take and you could distribute all of this out, and then you could do the power rule multiple times, but that's probably not the most efficient method once you know and get good at the power rule. So this is my u, this will be my v, okay, the first function and the second function, right? And the derivative goes like this. First, so x to the negative 2 plus 1. Times the derivative of the second. And also, with this, you've got to be really careful with your parentheses, obviously, because it's really easy to make a mistake as you go along here. So first times derivative of the second. So this would be 12x squared minus 6x. And I think that's kind of it. All right. And so then we'll take we'll go plus the second, which is 4x cubed minus 3x squared plus 1, times the derivative of the first. So when I take the derivative of the first, it'll just be negative 2x, subtract 1 from the power, that'll be negative 3. So negative 2x, oops, hold on, lose my spot here. Yeah, negative 2x to the negative third. And then derivative of 1 is 0. So that's it. So there's your derivative. Now we can simplify this. I don't really want to. I don't think you really need to. There are going to be some problems both on the quiz and the test where I say set up but do not simplify. This is one of those situations where, I mean, doing the algebra here to finish this out is not really an exercise that that I really care about because it's not calculus, it's algebra 2, and it's not particularly mathematically useful to do so, at least in this section. So let's talk about, so that's the product rule, that's it. First derivative of the second plus second derivative of the first, that's it, that's the product rule. Let's talk about the quotient rule now. So this is rule number 6, according to my notes here, quotient rule. Okay, so again, with the quotient rule, let's assume that we have two functions. In terms of x, they're both u, or each, they're both in terms of x. The functions are u and v. All right, and this is what we want to do. We want to take the derivative with respect to x of u over v. Okay, here's the rule for that. It is the bottom times the derivative of the top, so v du dx, minus the top times the derivative of the bottom. Okay, all of that divided by the bottom squared. Okay, so this one, you've got to be a little bit more careful than the product rule. In the product rule, let's say you mess up the order. You do second times the derivative of the first. Well, it doesn't matter because you're adding these. So if you reverse the order, it's not the end of the world. But here, with the quotient rule, we have subtraction here. So we have to make sure that we go bottom derivative of the top minus top derivative of the bottom, all divided by the bottom squared. Okay, we can't mess up the order here with the quotient rule. So let me show you an example where we're going to apply this. All right, so f of x equals x squared divided by x minus 1. Okay, so again, obviously the top function is x squared, so that'll be our u. That'll be v on the bottom. Okay, so let's go ahead and use the quotient rule here. So we have f prime of x. All right, we'll take bottom, which is x minus 1. So again, following the rule, so bottom function, x minus 1, times the derivative of the top. Well, that's x squared. Minus the top, derivative of the top. Good job, Cresswell, 2x. You got to be really careful. Okay, so bottom, derivative of the top, minus the top, which is x squared, times the derivative of the bottom. So x minus 1. If we derive that, I think we just get 1. Derivative of negative 1 is 0. Derivative of x is 1. So yeah, we'll just get x squared times 1. That's all divided by the bottom squared. So that's x minus 1 squared. A couple things here as we clean this up. On top, it's worth it to distribute this through because it likely will simplify the numerator. On the bottom, there's no reason to expand this because it's not going to make it any simpler. Okay, in fact, on the top, if we could combine like terms and then factor, that would be even better. So let's just simplify the top and see what we get. So on top, we'll have 2x squared minus 2x minus x squared. So 2x squared minus x squared will just be 1x squared. And then minus 2x divided by x minus 1 squared. And that's sufficiently simplified. If you took an x out of each one of these, that would be okay too. It's not going to get any better though. So there's our derivative with the quotient rule. All right, let's do one more of these, just to make sure you've seen a couple variations of it. As the functions get more complicated, the quotient rule will get more interesting. But here's one where I think the quotient rule is really the only tool that we have open to us. And maybe I suppose that was probably true for the last one too. X squared minus 1 divided by x squared plus 1. You should give this one a try and see how you do. And then speed up the video, yeah, sure, scrub through the video to the end, see if you get it right. If you don't, then watch the explanation. So here is the derivative. So I'm going to go bottom, derivative of the top, that's 2x, minus the top, that's x squared minus 1, times the derivative of the bottom, that's 2x, divided by the bottom squared, x squared plus 1 squared. There's the derivative. We can clean this up real quick, I suppose. It's not going to take us that long. So this will be 2x to the third plus 2x minus 2x to the third. Let's see, so minus 2x to the third minus 2x. Oh, plus 2x actually. Divided by x squared plus 1 squared. So I get 2x cubed minus 2x cubed and 2x plus 2x, right? Yeah, plus 2x, so that'd be 4x on top. So I end up with f prime of x equals, let's see, these are gone. And so I'll have 2x plus 2x, which is 4x, x squared plus 1 squared. And there's the quotient rule. Applied in a couple contexts. All right, so let's move on to something a little bit different here. If I give you, this is an example that throws students quite frequently, so I think it's worth sticking in the video here. Let's see, let's let y equal u times v, where u and v again are both functions, and what we want to do is we want to find y prime of 2 if the following are true. Okay, so if u of 2 equals 3, u prime of 2 is equal to negative 4, v of 2 is equal to 1, and v prime at 2 is equal to 2. All right, so again, you should give this one a try and see how you do. What we're going to do with this is we're going to take the derivative of y, and then we're going to see if we have enough information to figure out what the derivative of y at 2 is equal to. So let's just start with that. So in fact, let's go for a different color here just for fun. So y prime will be equal to, well, y is a product, so it's u times v. So the derivative will be u times v prime plus v times u prime, right? First derivative of the second plus second derivative of the first. What about y prime at 2? Well, y prime at 2 will be all of these things evaluated at 2. So this would be u of 2 times v prime of 2 plus v of 2 times u prime at 2. Oh, hey, that's everything that we have in the given to us here, right? So I have u of 2. So let's plug everything in. So this will be u of 2 is 3. V prime at 2, that's 2. V of 2, 1. And times that by u prime at 2, which is negative 4. Okay? So y prime of 2 is equal to 6 minus 4, so 2. Right? Okay. Fantastic.